Okay, so I wanted to speak about a mistake that I've seen made in some draft articles multiple times, and it has to do with time to event data. So let's start from the basis. Time to event data is a type of data that we have to encode with two different columns. So for instance, you have the ID of your patient, time to event data as, for example, overall survival is a type of time to event data. ID of your patient, time, but then you also have whether the event is observed or not. So in a typical Excel file, you would have patient 1, time 16 months, event observed, and patient 2, time 31 months, observed, no event observed, or patient 3, 81 months, event not observed, patient 4, 17 observed, and so on. So when we say observed equals 1 in the coding usually, and it means the patient is, for instance, dead in case of overall survival. But this also applies to other time to event data. For instance, you can have time to hospitalization. In that case, observed means hospitalized on that specific date that is reported in the time column. So in this case, patient 1 unfortunately died on month 16, day 16th, year 16th. The units of the time variable can be whatever you like it to be. And this, as we said, apply to every time to event data. When we have 0, it means censored. So it means that the event was not observed. So for instance, for this other patient, 2, we know that this patient was alive at 31 days, 31 months, whatever the units are. But we don't know if they died at 32, 85, 33, or whatever months. So going back to the basis, the reason why this was invented is that we want to use the information from patients that we know were alive until a certain time point, but we don't know when they died or when they encountered the event, whatever the event you want to be. So for this reason, there is a way to plot this data, and the way is Kaplan-Meier curves. Kaplan-Meier curves, I have another video that explains this better, but essentially it's going to calculate over time the probability of survival, or the percent of survival. And it accounts for both events, when the curve will drop when you see an event, but also for sensor data that is usually symbolized as ticks. Now, what is the error that I've seen done, unfortunately, multiple times, is to describe these type of variables with scatter dot plots. So for instance, you say, okay, here is my population, and this is the distribution of overall survival in my population, so, or in my cohort, better to be said. So this is my cohort, and this is the overall survival. And to extract statistical parameters or measurements of that describe distribution from this distribution, just like this. So for instance, they say, and this is an error, median OS equals whatever, 31 months. Okay, let's try to understand why this is a mistake. Because unfortunately, it is a little bit intuitive when you think about it, but sometimes it's not clear to a lot of people. So obviously the problem is that if you plot the time as such, you're not accounting for which observation is censored and which observation is an event. So let's just say we code the event, death in this case, as red, and the censoring as 0, and we code it blue. So I want you to imagine a situation where the same distribution that we just saw can be made up of different combinations of observed events and sensor data. So let's say we have the same distribution. I can just copy paste the same thing. Okay, so it's exactly the same. But in one case, so this type of plots are, as we said, blind to whatever is censored and whatever is an observed event. So let's imagine that in this case, we'll call it case A. This same distribution has a lot of sensor data at the beginning. Now I'm just coloring the dots that I already made, so I'm not adding observations. And then the ones that have a time that is longer are all observed data. Now let's imagine that in case B, it's quite the opposite. You have a lot of observed events for the shorter times, and then most of the longer times are censored. So if you were to just extract the median of these distributions in a scatter dot plot, they would be the same median. So median of A equals median of B, okay? But I want to show how when we account for whether the data is censored or not, the two distributions and the two median overall survivals are not the same at all. So I'm not going to calculate an exact Kaplan-Meier curve because it's beyond the point, but I just want to get a sense. So here you have a lot of events that are very late, whereas the cases that have short amount of time intervals are all censored. This means that a Kaplan-Meier curve will look as this for quite a long time with a lot of censoring, but no drops in the curve because there's no events observed. And then a lot of events are observed at the end. So your survival curve will look like this. And your median survival, this is 50% of the y-axis, which is overall survival probability, will be around here. So it will be, let's just say this is, I'm just making up a number, 100 days. Conversely, for case B, it's quite the opposite. You have a lot of observed events of death at the beginning and a lot of censored events around the time points that are longer. So your survival curve will have quite a lot of drop at the beginning, and then it will have a tail at the end, because these are all the sensor data with all the censoring up here, all the sensor data that were censored before observing the event, and they happen at the end. So as a result, if you want to see what the survival at 50% is, it's down here. So your overall survival is much, much shorter than the other case, let's say 20 days. So I hope this clarifies why, if you have time to event data that are coded as such, you cannot just simply extract the time column and plot it in a scatter dot plot to understand what the median overall survival is. The median overall survival comes from constructing a Kaplan-Meier curve, as we did. So this is not the right way of doing it. This is the correct way of doing it, and it accounts for sensor data and gives you a good estimate of what the median survival is. Now, another hint that happened. So, for instance, one of the cases where I discovered that there was a problem in a paper that was making this mistake was because they reported median overall survival and interquartile ranges of overall survival. So interquartile ranges of overall survival don't really exist as far as I know. Maybe I'm mistaken. Just because interquartile ranges is something that you extract from a scatter dot distribution, or I guess from a traditional variable distribution, not from a time to event distribution. So interquartile range of overall survival should raise a red flag, and you should ask, how did I calculate it? Because that doesn't make a lot of sense according to my experience. Now there's maybe some details that I'm missing, because the right way of doing it is not a good Kaplan-Meier curve. So you have a Kaplan-Meier curve. The correct way is to extract overall survival and median, sorry, construct the curve of overall survival and extract median OS time. If you want to give some sort of information about the distribution, which is what was the authors were trying to do with interquartile range, one thing that you can do is to calculate the confidence intervals. So there's going to be confidence interval bands that you can calculate with statistical software. And at this point, you can find when these confidence interval bands hit the 50% median. It would be here and here. So you can find the confidence interval of overall survival. So you shouldn't report, as we said already, median and interquartile range of overall survival calculated from the time column of the variable, but you should construct a Kaplan-Meier curve, calculate median overall survival from the curve, calculate confidence intervals if you want to provide some estimate of the uncertainty, confidence interval typically at 95%, and what is the median OS for the upper bound of the confidence interval and the lower bound of the confidence interval. So it will not look something like median OS 9 months, interquartile range, let's say 5 to 12. It will not look like this. This should be something that raises a concern. It should look something like median OS, let's say 9.8 months with confidence interval, let's say 7.2 to 15, something like this. Okay, 95% confidence interval, and it's calculated from the curve.